All right, how goes it, folks? We're starting up chemistry. I want to make sure that you folks all understand everything. Here's what I want you to do, Tejas. I want you to monitor the chat for me. I'm going to basically focus on this screen. I'm going to go through this as well and thorough as possible, but also pretty quickly. Slow me down if you need to, because I go fast with things. And I think half of you have had me actually in the past, and so you know how fast I go. Okay, let's go into this. We're talking about chemistry, and we're talking about, well, what is chemistry? So chemistry is, what it wants to do is it wants to understand the connection between the macroscopic world that we live in and that we experience and the microscopic world of atoms and molecules. Macroscopic means things that we can touch. It's things that, it's as small as maybe a grain of sand, things that we can still see. So it can be really big things, but macroscopic basically means you don't need a microscope to see it. I think that's my definition. The microscopic world is obviously atoms, molecules, and even like groups of atoms. You can't see groups of atoms either. You know what I mean? You can see incredibly large groups of atoms, and that would be like a grain of sand of something, But you can't see, like, I could see a large collection of sodium chloride, which is table salt. It's the salt that's on the table. But besides that, I can't see like sodium to the atomic level. You know what I mean? Without a microscope, at least. The hard part is in chemistry, we need to think of things in a really, really small level. So if I were to teach you physics, which is a class that comes after this, and often is very hard because it has even more equations than chemistry. If I were to teach you physics, I could take a tennis ball and throw it at your head. Well, maybe I would be able to have to throw it at your computer screen or at least my computer screen, because I can't do that. But if you were sitting in front of me, I could take a ball and throw it at your head, and you could see things moving around. Does that make sense? Whereas with chemistry, we don't have that luxury. Chemistry, you have to kind of see things operate at the atomic level.
Four of them have the same problem.
What is that?
Four of them have the same problem with the equations and didn't get the last four.
Oh, okay. I guess I can help you out with that if you need. All right. Matter. Matter is composed of tiny little Lego pieces called atoms. And this idea of an atom really was tough to kind of come up with. Originally, it came up with the Greeks, actually, were the original ones to call it. And they said, well, they asked the question, if I cut something in half, and then I cut something in half again, and then if I cut something in half again, and I keep on cutting that in half, is there a point where I can no longer cut it in half? That's the original question they posed. And so they said, there's got to be some point at which they can no longer cut it in half. Because you can't cut something down to like nothing. That's what they're saying. Does that make sense to you? So they came up with this concept of an atom as the smallest thing you can cut it down to. Now, we now know, because of the last 50 years of physics and chemistry, that an atom is made up of even smaller things, like protons, neutrons, electrons, and quarks, and that kind of stuff. But the Greeks were at least onto something. Are we cool with that? Now, we can have a molecule of something, and that's where two or more atoms are joined together, acting as one unit, as a collective thing. For example, water molecule is H2O, as in two hydrogens, one oxygen. Are we cool? And for those of you who had trouble with the equations, let me say this right off the bat. Chemistry has a lot of equations. And chemistry taught by a physicist has even more equations. So it's not to say I'm going to add more equations in there just to make it harder for you because I'm a math junkie and physicist and all that kind of stuff. Put the plastic back on the ground. I'm fine with you eating. Just put the plastic back on the ground so it doesn't make too much noise. Chemistry taught by a physicist has even more equations. And the reason why I'm putting you through the pain of adding more and more equations is, actually, I'm not going to add any equations. I'm just not taking out any. And the reason why I'm doing this is because I'm trying to get you to think analytically. This is the first steps of that. Does that sound fair? And I'll tell you what. since this is the first time, it's not the first time I'm teaching chemistry, but since this is the first time in a long time that I'm teaching chemistry, if I'm going too fast, let me know, and I'll try slowing things down. We have to go a certain speed to get through the materials. But if there's one thing I want you to know about Mr. Dalday, is first, Mr. Dalday doesn't speak about himself in the third person. And second, I think that he's quite understanding. Would you agree with that, Tejas?
Yeah, he's very understanding.
Okay, he's very understanding. Good. I'm glad. I'm pleased with that. All right. Now, we use subscripts to we use subscripts, and subscripts is different than subscripts in other sciences. In math, we use subscripts, and that means something different. I think one time in math, I remember talking to you folks about Taylor Swift and Taylor Lautner. Do you guys ever remember that story where I have I want to know the difference between T and T, and they're both for Taylor, so I'm going to call one TL and one TS. Do you remember that? Or what if we're talking about our temperature thing, and we're saying, well, I have temperature Fahrenheit, and I have temperature Celsius, and I have temperature Kelvin. Wouldn't it make sense for me to put a little subscript on the bottom, so I call one TF, TC, and TK? That's not a mathematical operation. That's just saying, that's just helping me identify between all the T's. Because if I want to use a variable to represent temperature in Kelvin, I would probably use the variable T, because that's temperature. And if I want to use a variable to represent temperature in Fahrenheit, I would probably use T, because that's a temperature. But if I want to distinguish between the two, I would give it a subscript. Kind of like if there's 2 marks in our class, we would call one mark B and one mark A.
Is there a mark in the class?
I don't even know if there's a single mark in this class. But if there were 2 marks in this class, and I'm sure that you've been in a group where there are 2 marks in that class, or in a group, or amongst your friends, or whatever, and you would call one Mark 1 and Mark 2. I'm sure that Mark 2 would always feel second to Mark 1.
Well, Mark 2 is better than Mark 1.
Yeah, Mark 2 it has a bigger number, at least. All right. He's always in second place. Okay. Well, I guess what I'm saying is the subscripts in chemistry mean something different. The little 2 on the bottom isn't to identify that, oh, I'm talking about oxygen 1 and oxygen 2. That's saying I'm talking about 2 oxygens. Does that make sense? Now, what's the difference between this and this? O2 versus 2 O's.
O2 is oxygen. That's 2 oxygen.
O2 is 2 oxygen, and what is 2O?
20.
No, not 20. This is supposed to be an O. If I mean 0, I'm going to write this.
Oh, okay.
The answer is nothing. There is no difference, really.
You can write it either way.
You could write it either way.
But why do you make the 2 smaller when you're writing it? Or 2, the 2.
This is where it's going to come into context, and it's going to start, as we start using these equations, you're going to need to pay attention to these things. And I can tell you the reason why now, at least. I'll tell you the reason why. Don't get confused with the next 1 minute of me speaking, okay? The reason being is because oxygen usually likes to bond with itself when it's just pure oxygen, so you see O2. So if we have 4 molecules of O2, we usually write it like this. We don't write it like this. Even though both of these are equal, even though both of these mean there is 4 oxygen present somewhere. We usually write 4 oxygens like this, because those O2s like to come as a group, and then you have 2 groups. That's why we write those things. But mathematically speaking, they're saying the same thing, 4 oxygen. Does that make sense? All right. But the point that I'm trying to make is I want to tell you guys the importance of a subscript, which is different than how we use subscripts in other sciences and other maths. Those things actually mean you have 2 of the object. If I were to write T2 in another course, that would probably mean time, the second time, or the second temperature that I measure, or something like that. But it wouldn't mean 2 temperatures. Does that make sense? I need to point these things out to you, or else you folks are going to get confused very quickly. Oh wait, I need to click here. Click here. All right. Science is a framework for gaining knowledge and organizing knowledge.
There's something about
O2 is bonded together, and 2O is 2 single oxygen non-bonded. Yes, exactly, Bradley. That's what it is. But essentially, what it means is there's 2 oxygen present someplace. Right. Okay. I have a question for you. Do you folks? I'm gonna straight up have to ask this because I don't have time to really go into this. But you guys know the scientific method? Do I need to go over that with you? Have you gone over it ad nauseum in your 8th grade science, 7th grade science, physical science, and biology class? Okay, good. I'm going to skip that for now if that's all right with you. But I do want you to know it. So there might be on the test, I might quiz on that even though I didn't lecture on it. I'm just warning you now. And my scientific method is pretty much the same one that I taught you back when I taught you 8th grade science, if I taught you that. Or physics or algebra or whatever. Same one. All right. So, more scientific method. All right. Let's get into some mathematics parts. Because to be honest with you, what courses have you had previous to this in science? You've had biology, and most of you have had physical science.
And biology again.
And biology again, whatever, I don't know. But I hate to say, and some of you even had conceptual physics. Did you have conceptual physics? No. All right. Not to say anything bad about those other courses, but this is going to be your first introduction to heavy math, applied math, as it applies to science. So this is where a lot of you folks are going to be saying, oh man, this is where this course gets hard. And I'm going to help you through this the best I can. But we need to talk about these things as best as we can. All right. Units of measurement. Actually all measurements need to have 2 parts to it. You need to have a scale a number and a scale. The number is just, we call that a coefficient. And you learned that back in algebra. The coefficient is just the number out in front of the letters, right? Mm-hmm. The scale is the units, and you need to specify exactly what kind of units you're talking about. If I ask you, hey, Tejas, how's your fever doing? And you tell me, oh, it's 98. Well, is it 98 Kelvin, or is it 98 Celsius, or 98 Fahrenheit?
Fahrenheit.
I'm assuming in this context it's 98 Fahrenheit, because 98 Celsius or 98 Kelvin means you're pretty much dead.
Well, if you're talking a fever, then I'd have to say Celsius.
Well,
98 is not a fever.
Yeah, 98 is not a. Well, I asked you how's your
question.
No, but I asked you how your temperature's doing. I didn't ask you how your fever's doing. I just what's your temperature?
I said, how's my fever doing?
Oh, okay. All right, fair enough. Fair enough. And by the way, 98 Celsius. Yeah, man, 98 centigrade. Your blood is 2 degrees away from boiling. That's pretty hot. Anyway, you would not want to be there. You also would not want to be at 98 degrees Kelvin, because you would be
dust.
No, you would be negative 100 and like negative 80 degrees Celsius. You would be frozen. You would be 80 degrees below freezing. That's not a good thing either. Okay. Anyway, so you need to specify the units that we're talking about. Are we talking about grams? Are we talking about joules? Are we talking about seconds? Are we talking about a joule second? Does that make sense? All right. So when we talk about mass, we often refer to, when we talk about mass, we refer to things as kilograms. When we talk about length, we refer to things as meters. Time is seconds. Temperature is Kelvin. Electric current is angstroms, or not angstroms, amperes. Amount of substance we actually call a mole. I'll teach that to you guys later on. It's abbreviated MOL, by the way.
What, dude? It takes too long to write an E.
Yeah, I know. What's the point of the abbreviation if the difference is an E? All right, that's a good point. By the way, what is the... These are the fundamental SI units. Do you know what that means?
I can't remember what SI stands for.
I think SI, I've always meant...
Standard.
Yeah, standard
In
industry. I don't know. I just remember as scientific. This is the science way of measuring things. It's also the way that the rest of the world, besides 2 countries, measure things. You want to know who those 2 stupid countries are?
us and us.
United States, and I think there's one that's close to like Burma or something like that. There's one like random Asian country that also uses the non-SI units.
Us. U.S. Us.
Yeah, but we're the main ones. We're the main idiots propelling this guy through. All right. What is the American way of measuring length? It's not meters. It's
The foot.
It's in feet. Okay, good. What is the American way of measuring temperature?
Fahrenheit.
Fahrenheit. Good. What is the American way of measuring mass?
Pound. Or is that weight?
No, not kilograms. We don't use kilograms.
Pound.
They're pounds. Exactly. Actually, we're wrong. Kilogram mass is not measured in pounds. And this goes into a discussion that you should have had in 8th grade science.
Ounces.
I think ounces might be it, but this goes into a discussion you've had in 8th grade. Actually, no, ounces is wrong too, and grams is wrong as well. This is a discussion you might have had in 8th grade science. Pounds is measurement of a force.
Right.
Pounds is a measurement of weight, as opposed to mass, and mass and weight are something completely, or not completely different. They're just different. Anyway.
Because you can have the same weight and different mass.
Yeah, that's true. Yeah. All right. Anyway, just to let you know, if you want to measure things, if you want to measure mass in American units, and don't remember this because it's the dumbest thing, but the measurement unit is slugs, by the way. SLUGS. I don't know how to abbreviate it.
For what?
Slugs. It's not abbreviated. That's the actual name. For mass. American version of mass is slugs. If you multiply slugs times gravity, you get pounds.
Never even heard.
Yeah, I know. It's dumb. Don't worry about it. I'm actually pointing that out because to show you that look how dumb our American versions are. So in chemistry, we are measuring things in kilograms, meters, seconds, time, or Kelvin, amperes, and moles. By the way,
That's weird.
we figured out something right, at least. We standardized time. So even though the rest of the world measures things in seconds, we also measure things in seconds. We don't have a difference. We decided, fine, we'll conform with the rest of the world in that regard. Why didn't we do the rest? I don't know. All right, anyway.
Because.
All right, this is really important. This goes into talking about scientific, let's see, it's called scientific notation. If I wanted to talk about, do you guys know about scientific notation? Is that something you covered in biology?
Yeah.
Yes, you did? Okay. It's really important. If I want to talk about like a gigabyte, how many bytes am I talking about?
1 million.
It's actually a billion.
Oh, it's a billion.
Yeah.
Oh.
You can look at this table, and after a while, you'll have parts of this table memorized. I'll tell you what, I want you to know, here's how much of this table I want you to know. I will expect to give you one of these problems on the test. What is a giga? You know? I won't ask you about a tetra or a peta or an exa.
What about a pico or a nano or a dec?
Or a pico or a nano or desa or whatever. But if I tell you pico, nano, or desa, and I say look it up on a table, I want you to be able to go back to a table and figure out what I mean. Okay? But things like giga, mega, kilo, deca, maybe not hecto. Hecto's a little weird, even though hecto is simply 100.
That's easy.
Giga, mega, kilo, deca, those are kind of important. Got it? And so if I say I have 3 gigabytes, really what I mean is I have 3 times 10 to the 9th power bytes. Does that make sense? Because a gigabyte is a billion. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9. That much. Instead of wanting to write out that big of a number, I simply convert it to 3 times 10 to the 9th power. We cool? All right. And
wait, isn't it 3 billion?
Yeah, and in this case, it's 3 times that number, so it would be 3 billion. We cool? All right, good. I have a question for you, and is that all I'm going to say about prefixes and suffixes? Does anyone have any questions about scientific notation? It's a tough concept, but I feel like you've learned it already. I want to kind of skip it. All right.
Google it.
Let me know if you need help, or use YouTube if you need help with that particular topic. Let's see. Yeah. In fact, to be honest with you, I just finished teaching my 6th grader a lesson, and I've been teaching him about, what do you know, scientific notation. So it's something I think that we can move on to. All right, uncertainty in a measurement. This is something important because I'm pretty sure that you have not encountered this in a previous class.
I have.
All right, and my answer is this, and maybe Tejas has, because he did a summer internship where he actually had to do actual science. But yeah, all right, Bianca, I'll tell you what, we can go over the homework today, but why don't we do that after class? After class is done. Is that all right with you? Okay.
I feel like there's more than her who wants to go over that.
Well, I'm fine with that. I'm fine with helping you folks, kind of giving you ideas to help you out with homework, but we'll do that after class. All right. Uncertainty in measurement. If I told you I weigh 183 pounds, would you believe me? Of course, none of you have seen me, really, so I mean, you can't really judge, but would that be reasonable? Sure.
I think you're being a little mean on yourself.
I just weighed myself. I'm actually that heavy.
No, but that depends on your scale.
All right. So what if I said I weigh 183.39678543921 pounds? Would you believe me?
Do you have that finite scale?
That's a good question. Say it out loud, Tejas.
Do you have that finite scale?
Tejas said, wow, you must be a drug dealer, because only drug dealers have scales that are that accurate, right? That's what you're saying.
And chemists.
Either a drug dealer or a chemist.
Unless you're both.
Unless you watch Breaking Bad, and in that case, what's the difference? Right? Okay. So what I'm saying here is, could I be 183.9487365129 pounds? Sure. There's no problem with me being that. The question is, how did you measure yourself to be that accurate? You say that, but how could you possibly know that to that precise measurement? That is ridiculous. You must have the best. You must be, getting your fat butt onto some kind of scale in some kind of national laboratory where you probably had to break in to get in there and then measure yourself to get that kind of pinpoint, super-powered, accurate scale. You know what I mean? And of course, for our cases, most people don't need to know their mass to that amount. Or maybe I was an astronaut and they need to know my exact weight because that goes into calculations or whatever. That could be it. Maybe it's reasonable for somebody, but certainly not Mr. Dalday. So if I were to write down all of those numbers, what would you say? Yep, yeah, you're right. That would have to be at the exact time that I'm standing on it, because 1 minute later I fart and then boom, I'm a little bit lighter. You know, I go to the bathroom. Hey, lost a couple pounds. Oh, that'd be kind of gross.
Shit.
Yeah, I know.
Shit.
Hey. No bad words in this class. But I'm just saying. All right. What I'm saying here is that, like, if I were to write down that many numbers, would you folks laugh at me? You folks would be like, you're being ridiculous. Like, that's dumb. You know what I mean? That actually makes me that writing that amount of numbers down would actually make me think that the person is not smart. The person that thinks they're all smart because they're writing down all these numbers, and I would say, a part of me would say, no, that's just proving to me that you don't understand what's going on. You see what I mean? Okay. Well, here's my point that I'm trying to make. Or would you agree with that?
I have to go get some water.
All right.
I'll take you with.
Okay. So, here's my point that I'm trying to make. And this is a very important one. I see students do it all the time. I've seen you, as former students, do this exact same thing. What people will do is they'll take a calculator and they'll write down all of the numbers in their calculator, and they'll write every single number down all the way up to 15 digits. And they'll think, well, I'm so smart because I got all 15 digits. And yet, they didn't really think about how accurate their measurement was to begin with. Now, Andre is asking, well, what's your point? Is it to just round up? And my answer is, well, it depends on how you round it. Because it depends on how careful you were to begin with. You see what I mean? So there's an uncertainty in the measurement, but I can't tell you round everything to the nearest tenth. Because what if you need precision up to the nearest thousandth place? Well, that just means you need to do your experiment carefully. But my point is, don't just write down all kinds of numbers, 3, 3, 3, 3, 3, 3, 3, 3, 3. That's ridiculous. It's, you know what I mean? You need to figure out exactly how accurate, to what scale your accuracy is, and then round it to that. Does that make sense to you? All right. Bradley, yes, I think that would be one of your, I think that on one of the questions I asked, on one of the quizzes, that's the problems that you would have. The answer is 0.333, and I wanted 0.3300 or something like that. I'll take a look at exactly what one of those things. Because you could have a bunch of uncertainty numbers that wouldn't help. Yeah, exactly. All right, so let's talk about this stuff. All right, here's where we go. So let's take a look at this burette. And this is actual chemistry here. When I measure things, I want to measure, all right, tell me where this thing, how much is in here exactly. And you know what? I disagree with what they're saying. This looks to me like it's below 20, doesn't it? Like, I disagree with their picture completely. It doesn't make any sense to me. What are they talking about? Huh. All right. First of all, we need to figure out where to measure this. Do we measure this right here? Or do we measure this right here, or right here, or right here, or right here? And Bradley's throwing out the word meniscus, and I agree with Bradley completely. The word meniscus means, oh, I get it. Yeah. This does make sense. Yeah. Courtney pointed out something. I was like, this doesn't make any sense, but you're right, Courtney. The numbers are going down. So this is 20 and this is 21. So this is a little bit above 20. This thing is, we're talking about how much is drained out of this. That's how these numbers work. Anyway, first of all, there's that word meniscus. The meniscus is, whenever you're measuring something inside of a tube,
There's a curvature.
there's a little curve on the bottom, and you always choose the lowest point of that thing. That is to standardize things across the board. Everyone does it. Everyone has decided to do that as a standard thing. And it's because there's there's static clinging, internal forces that are clinging, that making the thing cling to the sides. But anyway, we're talking about the meniscus, so we measure things at the lowest point. Right here, exactly right there, that is 20.1. Do you agree? And exactly right here, that is 20.2. Do you see what I mean? So how much can you tell me it's at least? It is at least exactly 20.1, right? So I can say Garens Bobarens, this thing is at least 20.1. Now, I would have to say, okay, wait, there's a difference in my, some people could say it's 20.5. Some people could say it's 20.6. Some people could say it's 20.4 or 20.3. I don't know. Or, 20.16 or 20.14 or 20.13. Does that make sense? So I guess the point that I'm trying to make is you can't measure it past this number right here. Here's my certain digits. I can always go one measurement past my certain digit as my estimated. Does that make sense? But I would have to say something like uncertainty of plus or minus 0.01. I would have to say something like that, because that tells me which digit I guessed. We cool? And so you can't report more than 4 numbers. So I think it's ridiculous when people use a calculator and they tell me, well, I calculated it out and it's 20.157864.
You really just need the first 2 decimal places.
Well, then I say, what kind of eye do you have? Because my eyes can only see 20.1 for sure, and then maybe 5643. I don't know what goes in there. You know what I mean? But I ain't Superman. I can't tell you that precision. So I'm going to mark you wrong.
Is that precision or accuracy?
Okay. Here's what precision is and here's what accuracy is. There's a difference between precision and accuracy, and I think that the best thing to, well, let me see. Let's not talk about that until we talk about this, this example, okay? To analyze a sample of polluted water, a chemist measures out 25 milliliters of water in a sample pipette. See figure 1.6. Oh, okay. A pipette looks like this. I didn't put the figure over here.
I like pipettes.
Pipette looks like this. This, and you just have water in it, and you try to measure out a line.
What kind of pipette
All right.
are you using?
Fine. A pipette sometimes looks like this, right?
Yeah, or there's the automatic one, the clicky one.
Yeah. All right. The pipette right here is, I think that this one's the one where you suck up the liquid over here, and then you just use your thumb and you drop it down to the line where it's at.
Yeah. Okay.
All right. Anyway.
That's old school.
Yeah, that's old school, and people don't like sucking liquid up inside because if they're talking about chemicals here, you accidentally go, and then you die. So let's see.
Chemistry.
At another point in the analysis, the chemist used a graduated cylinder that was 25 milliliters of solution. What's the difference between 25.00 milliliters of solution and 25 milliliters regular? So here's what I'm saying. A graduated cylinder looks like this, and I'm sure that you folks have seen it like that. Looks something like that. And so I measure one that has a pipette, and I measure one using a graduated cylinder. What's the difference? This one's 25.00, and this one's 25 milliliters. Numerically, what's the difference? Numerically, which one's bigger? Neither. I agree. They're both 25. But what's the difference with 0.00 and the other one. The uncertainty in the last number. So yours is 25.00 is more accurate. Yes, I can almost guarantee you that there's. I can tell you there's exactly 25.0, and I don't know whether or not it's exactly 0.0 for the last number. Whereas this one, I can't tell you whether or not it's 25. It could be 26. It could be 27. My eyeball just couldn't tell that big difference. You see what I mean?
By the way, that looks more like a volumetric class than a graduated cylinder.
You're right. A graduated cylinder is just a cylinder.
No. Oh, yeah.
It has a little spout right here.
Yeah.
You're right.
I spent a lot of time around all that stuff.
Yeah, I know. It's been a while. It's been like 8 years since I've done chemistry. All right? But I'm good at it too, so I just don't remember the lab stuff. All right, there's higher and lower uncertainty. I totally agree with you. I'm going to skip this precision and accuracy thing because I think it's a very important conversation to have, but I think it's a conversation that you folks can have later. All right, significant figures and calculations. So I talked to you about writing things down and writing numbers down to ad nauseum, just writing numbers and numbers and numbers down and thinking, oh, I'm so smart because I'm doing this. But that's ridiculous. Don't write that. I know that class is finished, and I apologize for going late on my first day of lecture, but if it's all right with you, I missed last week's lecture because I couldn't teach last week because they didn't tell me which classes I have. So I feel like I need to get through section 1.5 with you at least. And I'll tell you what, why don't we take a look at this? If you let me get through 1.5, I will. Let me look at something real quick.
How long do you think that'll take? I have to be somewhere at 4.
I won't be till 4, I guarantee you that. If you let me get through chapter 1.5.
He said give us an automatic A.
Actually, you know what? I can stop here. I'll tell you what I'll do. I'm going to take the significant figures quiz and I'm going to move that back to Wednesday. So attend class on Wednesday because it'd be unfair of me to ask you to do significant figures without me lecturing on it first.
Class is longer on Wednesday, yeah. It's like
Class is a little bit longer on Wednesday. All right?
Okay.
Now, I won't be taking the full 2 hours every Wednesday. I just put that 2-hour block in because every other week we have an actual lab that we want to do.
Are we going to do it in person?
I'd like to do this labs in person. I'd like to actually have some awesome labs for you. But I'll tell you what I'll do for now is I'll move the homework that's due on Wednesday or on today or tomorrow to Wednesday, and I'll move the homework that's due on Wednesday to Thursday. Sound good?
Yep.
That way I have a chance to lecture on this for you. All right. At this point, class is over. I will let you go. However, if you want to stay and ask questions about temperature, by all means, go for it.
I don't really have a lot of questions yet because I didn't take it yet.
Oh, you didn't even try it.
Not yet. I'm going to.
You better try it, dude.
I know. I had a lot going on today. I just moved back to my mom's yesterday. So.
You can't ask me to do the whole problem for you. That's not allowed. I don't know how to do this problem. Can you do the whole thing? Well, where did you try? I didn't try anything. I'm just asking you. Am I positive question number 7 and number 9 are correct? That's a fair question. Let's take a look at it. All right, let's go here and go to temperature. Let's see. Chemistry.
Someone said, Sophia said number 7 isn't right.
Okay, 7 isn't right. All right, fair enough. I will look at it right now. Ah, yeah, that's right. Sophia told me there was a problem with one of the things, and I changed the answers, so I gave you guys 6 attempts instead of 3 attempts.
Did you change the question?
All right, let's see. Now, question number 7 was number 59. All right. Okay. All right, and what did I ask? I'm only looking for Fahrenheit here on 59. Whoa, that is a high temperature. All right, let's edit this quiz and see what I wrote. So now you guys see the answers without seeing that, or me even doing it. I'll tell you what did you guys write down? You guys wrote down 102.56. I wonder if I told you you have to write down exactly my answer. All right, let's see.
That's a fair point.
Yeah, I should give you guys some leeway. No, this one is correct. And I'm sure that the other one's correct. You guys are like, oh, that's the answer. Oh, look at that. That is not correct. All right. Unless you put in negative 13, you didn't get the right answer. So I messed that up. I'm sorry. This one's weird too. Oh, I see. Is this right? 59 part. Oh, I know what I did wrong here. I put an A and that's supposed to be a D. All right. Sorry. All right, I think that takes care of question 7 and 9. What did you get for the answer for question 9?
Is it 320?
320. That's not what I got. Oh. Okay, what did you get? All right. So it looks like the reason why you guys got all screwed up is because Mr. Dalday screwed it up, not because you guys did it wrong. Let's try it. Let's do the melting point of sodium chloride is 801 degrees Celsius. Now you guys are like, wait a second, this wasn't question 9. And my answer is, yeah, I accidentally asked you the wrong question. Yes, for now, can you guys retake that to get full credit? Or I'll tell you what I'll do is I'll go through and whoever took the quiz, this particular questions in the quiz, I'll give you full credit for that. But Tejas, you didn't take it, so you got to go and redo it yourself. Let's talk about this one, though. 801 degrees Kelvin. And in order to convert that into...
Celsius.
What do I need? I wanted it in Kelvin, right? Or Fahrenheit. Do I want it in Fahrenheit? Or
You wrote Celsius on the screen.
Yeah, I know. I wrote Celsius. But when I asked you in question 9, I was asking for Fahrenheit. All right. Yes, for both questions, by the way. All I wanted you to do, convert it into Fahrenheit, is basically plug that into the equation F equals 9/5 C plus 32. So you basically just plug that into there, and you should get something else. Matthew, should you retake it? I'll tell you what, if those are the only 2 questions you missed, don't retake it. I'll just go in and change that thing. I messed it up. That was my fault. All right. I apologize. And again, I have to say this. Look, nobody gave me anything to work with, so I need to actually make the answer keys and then build the quizzes and do things. It seems to me that the only mistakes I made were 2 typos. Instead of an A, I put a D. Instead of a, negative 13, I put a negative 13 instead of putting like a 120 or something like that. So I typed the numbers in wrong. I apologize ahead of time for my mistakes. I make them. And I'm completely fine with owning up to them. But yeah, let me know. Yes, you should get credit because I said that I told the computer the answer was 102.6, give or take 1. So you could put in 102.56 and that should still be within the range of getting the answer correct. So hopefully for future generations, that quiz is fixed. For future generations and the people who are retaking it. But I see your point, and yes, I acknowledge that that was my mistake. Go and don't worry about it, I'll fix it for you. How do you know which way the 9/5 or 5/9 goes, converting from one temperature to another? How do you know which way the 9/5 or the 5/9 go? Okay. Let me think about how to answer that. Let's see. If I want to convert this to 5/9 Fahrenheit equals C minus 32 times 5/9. All right, let me think, hold on. Because I need to tell you a story. How do I remember whether it's 9/5 or 5/9? 5/9. Okay, so can I think about that and get back to you? Oh, well, I can tell you the answer as to why. I need to do a little bit of thinking as to tell you how to remember it. The reason being is because there's two equations you could know. You could either know C equals 5/9 Fahrenheit plus 32. Well, it wouldn't be 32. It would be something else. And let me actually just make sure I'm getting the right equation. Yeah. It would be 32. What is 32 times 5/9? Anyone got that on their calculators?
What?
What is 32 times 5/9? Or what's 32 times 5? 160?
Yeah. Over 9.
So you could either memorize the equation Fahrenheit is equal to 9/5 C plus 32, or you can memorize the equation C equals 5/9 minus 160/9. Or 5/9 F minus 160/9. I would rather do the first one. But how do I know whether it's 9/5 or 5/9? Well, or how did I get this equation from this equation? I just solved for C. And the reason why I flipped over that fraction is because I'm trying to get rid of the fraction off of this C. So in order to get rid of the 9/5, I multiply by 5/9, and that gets rid of that. Does that make sense? All right, I gotta go. You gotta go. Talk to you later. Okay, bye. I hope that made sense.